Okay, now we're looking at other types of equations and how to solve them. So we have polynomial equations. These are just kind of a mixed review of things that you've done some of before. So here we have x cubed minus 9x equals 0. So if you want to try this one on your own, go ahead and do that. I'm going to work quickly through it. So we have to first factor. Well, we're going to look to see if it's set equal to 0, what we want to do. Is it factorable? And yes, it works out nicely. It doesn't even have a coefficient on this first term, so that's kind of nice. So we just can pull out an x, and then we're left with parentheses x squared minus 9. Set it equal to 0, and then we're going to factor. So x is already factored out, and then we have a difference of two squares, x plus 3, x minus 3 equals 0. So we're going to set all of those equal to 0. You can probably not have to write that out all the time, but just so we're sure, we would set x equal to 0, or x plus 3 equal to 0, or x minus 3 equals 0, and then we go ahead and solve for all of those. So our answers would be, we could write it in set notation or just as x equals 0, comma, negative 3, and 3. We do want to put those in numerical order, so I'm just going to rewrite them as x equals negative 3, 0, and comma 3. So that would be my answer. I could put them back in to check. You can do that to verify, or if I asked you to do that, you would just plug each one in and make sure it works. In this type, it is a polynomial, so it should be fine. If it's a word problem, you may have an answer that doesn't make sense to be negative. It's out of the domain, or even a 0 might not be right, or something that's too large. So you do have to kind of consider that. But when we have other types that we're going to see soon, the rationals and the radicals, we really have to be much more careful. So for number 2, off to the right here, x cubed minus 4x squared minus 5x equals 0. That's very similar. You're going to pull out an x first and then factor it and solve. So go ahead and try that one as a try it. Or if you want to just watch the video, I'll do it quickly, but pause and just at least attempt it. Okay, so I wrote this up already. X times quantity x squared minus 4x minus 5, and parentheses equals 0. So that is my first go at it, getting out the greatest common factor. Now I look at that trinomial and I can factor that also. So I have x times binomial x minus 5 times x plus 1 equals 0. Set each factor equal to 0. I get x equals 0, or x equals 5, or x equals negative 1. I do want to write those in numerical order, so I'm going to write x equals negative 1, comma, 0, comma, 5. On your key, you may see it with the braces and then in set notation, very similar. Either one of those is okay. Okay, now this one's just a little bit different for you. My greatest common factor is going to be a squared term. So number 3, x to the 5th minus 8x squared. So I can actually factor out an x squared. And then I have parentheses, x to the 3rd minus 8. This is actually this x to the 3rd minus 8 is a difference of 2 cubes, so that kind of has its own special thing that we don't get too much into in this course. It might come up, but the way we're going to do this, it'll work out really nicely. So set each factor equal to 0, x squared equals 0, or I would have x cubed minus 8 equals 0. Now x squared equals 0, I just take the square root of both sides and I just obviously get 0. Now this difference of two cubes here, I can go x cubed minus 8, subtract the 8 from both sides, I get x cubed equals 8. And then I can take the cube root of both sides, and I would get 2 for my answer. Because the cube root of 8 is 2. So then I can just write my answer. I'm going to write it in set notation here because I like that. So I have 0 or 2. Next problem is number 4, x to the 4th minus 64x equals 0. I think you would just start by, well, you look at it and see, pause the video, and what do I always say? Factor out a such and such, and we'll see. Okay, so I factored out an x first, so it was x to the 4th minus 64x equals 0. Factor out an x, and you're left with x cubed minus 64 as a binomial in the parentheses. Set each of your factors equal to 0, so I have x equals 0, and then I take the cube root of the x cubed equals 64. I'm going to take the cube root of both sides to get my x by itself, and I'm left with 4. So my answer is 0, 4 in set notation with the braces. So this difference of two cubes or sum of two cubes has a special pattern. If you were to see that and need to factor it out like the long way, then I will post separate videos for that. I don't want to do it in this one right here, but we don't get too much into it, but I do want you to see how that works out. Okay, so number 5 is x cubed minus x squared minus 3x plus 3 equals 0. The way to handle that one is I have 4 terms is I'm going to use factor by grouping. I do want to double check, can I pull out a GCF? And I can't because there's no x on that last term there. So I'm just going to do factor by grouping. So I can split them up into pairs, and then I look at x cubed minus x squared, and I can factor out an x squared, and that leaves me with x minus 1. Now, don't forget that subtract has to stay there. I know that people struggle with that, but that is a subtract. It's not multiply. Don't go and FOIL these two together. We're just kind of grouping, but leaving the symbols for now. And then 3x plus 3, I can factor out a 3, but when I do that, I'm actually going to pull out a negative 3. Remember, this is kind of like plus negative in the middle there. So I would have a minus 3 parentheses and then an x minus 1, and if I checked it back, I would have minus 3 times x gives me my positive 3x, and then minus 3 times minus 1 gives me my positive 3. So then the last step is this x minus 1 is a binomial, but that's also my greatest common factor that's common to both of those, so that pulls out. And then what's left here, this x squared minus 3, that is also a factor. It's not a difference of 2 squares because the 3 isn't squared. So, you know, you kind of think, well, it's not a perfect square, but we can actually take the square root of it and it works fine. We can do plus or minus. So I'll show you, we're going to use the square root method to solve the rest of this out. So we're going to set x squared minus 3 equal to 0. I should carry down my equals 0 on the right hand side. Or I have x minus 1 equals 0. So I can use the square root method here. X squared equals 3. Take the square root of both sides. And that's kind of thick there. And so I have x squared equals 3. and x equals 1. So I'm going to take the square root of both sides for x squared equals 3, and I end up with x equals plus or minus square root of 3, or x equals 1. So to write my final answer, I would write a brace there, minus square root of 3, and then 1, and then positive square root of 3, just like 1.7 or something like that. So that would be my final answer on that one. Now number 6, you'll notice has a little typo in there. So we have x to the 4th minus 3x cubed minus 4x squared, and that should be a plus 12x. Okay, plus 12x equals 0. So sorry about that. Do make sure you go ahead and fix that if I haven't edited it before you get this, and print it. So what you're going to do is use the same process, factor by grouping, but do notice that there's an x in each of these terms. So you can pull that out first. That'll make things a lot easier to deal with. But don't forget, when you do pull out just a single x like that as a factor, to set that equal to 0 also. Okay, so go ahead and do that one as a try it. And I will work that out, and then you can check back for the solution. So I went most of the way filling out the steps, but I'll go through them quickly. X times x cubed minus 3x squared minus 4x plus 12 and parentheses equals 0. So that was my first step, factoring out the x. And I'm just writing myself a little note here, x equals 0. Don't forget to bring that back down eventually. I could just, kind of carry it down here as well. And then I'm going to pull out of here, looking at this 4-term polynomial. I've grouped my factor by grouping there. I pull out an x squared, and then I'm left with x minus 3 in parentheses, and then I have a minus 4 that I can pull out on the second grouping, and I have x minus 3 in parentheses. So that x minus 3 becomes my common factor, so that pulls out there, and then what's left is the x squared minus 4, but I also have to bring down my x. So I'm not quite done, because this x squared minus 4 is a difference of 2 squares, so I want to write that as x plus 4x minus 4, or I could just use the 2. I could just use the square root method there, and do it that way. And now I have this whole big string here of things to fill in. So I would set each of these factors equal to 0, and I end up with a minus 2, and I end up with a 0, a 2, and a 3. So those are all my answers. So there's 4 zeros in that polynomial, so across the x-axis 4 times there. So I'm going to stop there for this one. I will just jot down the pattern for the sum of 2 cubes, but then I'll post a different video just of probably James Souza going through that with you. But I'll put the pattern up here too, so if you want to check that out, you can. So this is just your little note for difference of 2 squares, if you want to jot that down for later. 2 cubes, actually. So we have a cubed minus b cubed equals a minus b as a binomial times the pattern will always be a squared plus ab plus b squared in parentheses. And then for the sum of 2 cubes, a cubed plus b cubed will be a plus b binomial times trinomial a squared minus ab plus b squared. And you see this little SOAP, an acronym there. to help you remember. Same opposite sign, so the same sign, opposite sign, and then always positive is that last one. So if you have to factor that out the long way, or do like you could do long division and things like that, when you multiply the binomial and trinomial together here, you end up with the difference of 2 squares. So that's kind of a shortcut, either direction you're going. Just want to point that out.